Good afternoon. Our co-investigator team is providing this video and audio recording to demonstrate the principles behind our research proposed in this proposal. We are also providing this video and audio as a mechanism of how we can disseminate the information and knowledge that we developed during this project. Thank you very much. So you see in the video two bottles of reagents, one labeled A, one labeled B. The A bottle is a binder composed of saponins. These are hydrophobic molecules that we have developed here at Texas A&M University, capable of binding to surfaces. The B bottle contains a silica-based coating, which is FDA approved for use in food processing systems. You can see the researcher is beginning to prepare the mixtures for application onto a model surface that we're going to use for this video's purposes to simulate produce packing post-harvest equipment. So we're going to load the two reagents into their respective spray bottles to allow us to apply them to the model surfaces. And so first off, we're loading bottle A with the binder again. And this will be sprayed on first prior to the coating, as you'll see in just a few moments. Closing the bottle, fixing the sprayer, and then we'll repeat this process for solution B, which is the coating solution. And again, the binder solution will go on first on the model surface, and then the solution B, the silica-based coating, will be applied thereafter. Filling the spray bottle. Now, for the purposes of this video, we're going to be spraying small volumes onto a small piece of plastic equipment used to simulate post-harvest. However, for industrial purposes, obviously these two liquids can be produced in much larger scale and can be added into a vat or a tank or a bin or some other type of container. They need not only be applied via spraying, they can be mixed and applied. There are a lot of opportunities for our research team to develop easy, simple methods for growers in order to apply them and use them in their packing sheds. So you see two plastic containers, same size, same angle of incline. One says coated, one says uncoated. The uncoated is going to serve as our control container, and the plastic is just designed to model conveyances, washing systems, anything, other types of plastic systems that a grower might be using in his or her packing shed. These systems can also work on other types of surfaces, such as stainless steel, but we're just going to model plastic for you for this video. So the researcher is spraying the binder, the pre-coating, onto all the edges of the surfaces of the coated or the treated plastic bin. Now, you can allow that binder to dry fully, visually dry fully, but you need not to, as long as the grower, as long as the grower gets full coverage of all surfaces that would make food contact or adjacent surfaces, there is good utility in the binder. All right, so now we have treated the binder onto the surface of the coated, the treatment container. We're now going to apply the silica-based coating solution, and we're going to spray it on top. As you can see, not all the surfaces are completely dry yet, but that doesn't matter. It's still going to react and set up a coating that will repel microbial attachment and biofilm formation. So you can see the coating being sprayed on. All right, covering all the surfaces. And now we're going to just go in and make sure we've got all the surfaces covered, every centimeter that we can find, every square inch that we can find, make sure we got full coverage. And now what we need to do is allow the surfaces to dry, the coated surfaces to dry, approximately anywhere between an hour to 2 hours minimum. Required drying is optimal. A grower could be given instructions and would be given instructions on how to properly dry, how to properly apply, so an SOP would be developed. Now, post-drying, you see the two containers, the treated coated container, the one on the right, and the uncoated control on your left. And you can see the development of the white film, the white coating, visually present. The researcher is holding a bottle of water that contains potting soil, purchased locally in College Station. And so we're just going to pour this, and as you see that water flowing over it, you can see, of course, the water collects at the bottom, but the particulate matter, the composting, the soil can collect in it. Collects at the bottom, but the particulates, obviously, this soil could contain microbial pathogens. In relationship to the FDA's Food Safety Modernization Act and Produce Safety Rule, we know that manures, compost, other types of biological amendments need to be treated or managed for the sake of food safety risks, not transmitting to final produce. During harvest, dirt may come in which could bear pathogens that would then cross-contaminate systems. However, as you've just seen, on the coated surface, the water beaded and did not collect, it did not dry or reside or spread on the surface, but due to the chemical nature of the coating, the water beads and the pathogens that may be attached to pieces of soil, dirt, twigs, leaves, other types of biological materials does not bind and does not give opportunity for biofilm formation. So you can see in this video how we've developed some very simple, easy to apply, safe technology for the prevention of biofilm formation in fresh produce packing operations. This video is an example of how we can disseminate the knowledge that we're gaining from these types of research activities to growers in a very straightforward and simple fashion, as well as to assist other food safety stakeholders on how to effectively and simply protect produce safety in the harvest and post-harvest environments from sanitary conditions loss, from biofilm formation, and from cross-contamination from washing waters or other agricultural or other purposed waters during produce handling.